All right, in the interest of time, why don't we go ahead and get started here. Good afternoon and welcome, and thank you for attending this session, which is part of the overall migration and transformation track. My name is Joe Healy. I'm a principal consultant within AWS Professional Services based here in Herndon, Virginia. I'm joined today by Zachary Kelly, who's an associate VP for enterprise engineering from a partner 1901 group. And you'll learn a lot from him and the capabilities of their company, especially in the areas of managed service and migration. And together, we're going to provide an overview of what a landing zone is, why it's important, and how you can actually implement one. Before we begin, I want to kind of review a scenario with you to kind of set the stage a little bit. You know, your organization may have the opportunity and kind of the doors open to integrate the public cloud capabilities within your existing portfolio of services. You know, this may come in different flavors. It may come into the notion of, you know, dealing with capacity constraints, cost avoidance from a tech refresh or data center renewals, cutting costs overall. You know, trying to deliver value faster, developing a DevOps mentality within your organizations, and kind of getting more cloud native when necessary. Oops. So being an enabler, you're buying in and you're looking to help deliver on those objectives for your organizations. So you enable and you work with your organizations to provide them the access and the tools to actually making progress against those and doing this fast, whether they're ready or not. And with that, kind of you've succeeded in helping them move fast. But this may be the result that you're starting to see. You know, there's no governance or standards that are being followed. You know, security being one of the key ones. You know, it's a bit of a Wild West approach. You kind of figure it out as you're going along. And you may have a result of higher costs, not just from a resource perspective, but how are you managing this? And worse yet, the infrastructure becomes extremely fragile to where no one wants to touch it. And you know, one bad move can make things collapse. And many times this is a kind of a pattern that you're moving away from, or trying to move away from, and here you are recreating again in your new environment here. And then your management and kind of leadership kind of gets involved, and they come up with the notion of, you know, there has to be a better way of doing this. But you're left there thinking, you know, I thought we were being agile or cost effective or secure, or whatever the other adjectives you want to put there. And you know, moving to the public cloud is going to be so easy. You know, AWS is really just going to be another data center that we're integrating with. You know, that's a common approach that you take. It's just another extension of how you're doing things. But in reality, a true adoption of AWS requires many aspects of your organization to transform and evolve. You know, focusing just on the technical components, although tempting, kind of helps you focus on things the wrong order, or you end up with that big of a ball of spaghetti view of your infrastructure that we showed a couple slides ago. You know, presently there's a lot of decisions that are presented to you, and you really might not know which ones to focus on, right, or what's the impact of making the wrong decisions, or really where to start. You know, the overall goal of this migration track itself in this session is in particular just help provide some clarity and some guidance and some options on how you can properly start your migrations to AWS. You know, the overall migration track itself, just a review and showing where we are, obviously, it's just a way of presenting the overall migration methodology that AWS has developed over this last few years and worked with many different customers. If you haven't been able to attend any of these sessions, I highly recommend seeing them, and we're going to be posting all this on our AWS YouTube channel shortly. But as you'll see, we'll do a quick review of the methodology itself, but it's doing a lot of work up front and doing a lot of preparation from a readiness standpoint versus focusing solely on the execution of the migration itself. And the actual migration methodology is spread over 3 phases. As you can see, it's from a readiness assessment, which feeds into an actual planning exercise where you're addressing the gaps in the actual delivery of the migration. So, like I said, focusing on the actual migration task itself may be tempting, but doing the front-end investment of properly assessing where you stand and preparing yourself for the actual migration themselves. So with that, in phase 1, it starts with the readiness assessment, which is, right now, it's a questionnaire that is aligned against the cloud adoption framework, which I'm not sure if you guys are familiar with. It's on our website, but there's 6 perspectives that are spread across both split between technical and business components of your organization, which help you form some guardrails as far as what are the impacts on my organization when I'm doing a true adoption of AWS itself. So these questions help you draw out where you are from a readiness perspective, and at the end of this phase 1, you're doing a detailed analysis on those results, which feed into creating a scoped engagement with you and doing a readiness and planning engagement with your organization to address those gaps. It formulates into a series of sprint-based work streams, which are aligned to the CAF perspectives. And these CAF perspectives are, your readiness against these CAF perspectives are then further validated by taking a set of representative applications through an actual migration. And then you're validating yourself against the different components and assessing yourself from a readiness standpoint. And you're also, during this phase, you're developing a very detailed business case. So you understand the costs of what this new normal is going to cost and the actual costs of the migration itself. Obviously, there's only so much accuracy you can have, but you're collecting a lot of detail, and it's a very good business case you're creating. But also going through the actual application portfolio analysis, you're able to develop a very detailed migration plan as well. And with this migration plan, you're able to move forward with the third phase to actually execute the migration in the various paths. One key part of the MRP engagement, the phase 2, is within the platform CAF perspective, and it's dealing with the landing zone, and that's what brings us here today. And what is the landing zone? It's really just a culmination of many best practices that have been identified and refined over the years. It's based on a lot of lessons learned and working with many customers, and they're preparing these organizations for their cloud adoption and migration journeys. Each customer is unique, though, but there's a common set of best practices that's going to be leveraged amongst all of them. The landing zone concept itself is not prescriptive. It's a way of allowing these best practices to be incorporated where they make sense with each customer, allow them to be adapted where necessary to meet the specific requirements, but also take into account future adaptations that are necessary without having to circle back and address them and have a very highly disruptive impact on your architecture and your account designs and things like that. In the following slides, we're going to cover some of the core tenets of a landing zone, as well as some different implementation paths that are available. Everything with AWS itself starts with an account. Many times when customers are starting out with AWS, they use a single account for everything. And they start pouring all their environments, all the resources into that single account. And not until they start scaling, they start running into some unintended consequences, usually related to risk. And as you're co-mingling things, the impacts of mistakes start growing. So by taking a little bit more of a distributed approach to your account design, especially initially, this is a good practice to start off with, is segmenting your accounts to address some of those unintended outcomes to help prevent them from happening. So doing things like creating a central security account to centralize your log information, especially from an audit and operational logs. This allows you to develop, with the right tooling, a single pane of glass to not only manage, but analyze and correlate all this data, all layers of your infrastructure. Then moving into the billing, providing a consolidated view of your infrastructure and creating that feeding of that billing data into a master billing account, where there's no resources in there at all, it's just there from a reporting and analytics standpoint, allows you to get a true cost of an environment, as well understand the impacts of changes with them, and also incorporate it into your governance aspects related to costs. There's many common services that are leveraged throughout your entire infrastructure. Centralize these into a shared services type of account or a management account. It comes under different names. Allows you to centralize things like your directory identity management or other common services that are identified in working with the customers. It allows you to streamline your operations and reduces administrative burden while enabling you to enable these types of services to be leveraged consistently throughout your whole infrastructure. And lastly, providing the proper isolation between your environments is crucial, especially when you're dealing with prod and non-prod, not commingling, but more importantly, when you're dealing with data classification levels. Either from a compliance requirements or just from best practice requirements, you want to isolate these so that the impacts of mistakes being made, especially if they're being done manually, are limited and contained as much as possible. Planning things out on paper how they should work is one way, but you need to take an alternative approach and looking at if something went wrong at these different parts of my organization and these changes didn't go as planned, what is the impact of that? And that's where you need to start figuring out how distributed I need to make this approach to how I design my accounts. Now moving into identity and access. Many of the organizations or even your own company, you have some concept of a directory right now. Usually that translates to Active Directory. Well, leveraging that as much as you can from an authentication authorization perspective makes a lot of sense. There's just a lot of benefits to that. One, you're not reinventing the wheel. You're able to get things going very, very quickly. Two, that directory is generally integrated with an existing HR policy. So dealing with onboarding and offboarding resources. Onboarding allowed them to get to work much faster. Offboarding, you're not having the concept of zombie accounts and having stale accounts and more attack vectors for those stale accounts. But also you're not creating individual IAM users throughout your own infrastructure. One, it's another administrative burden you have to maintain. But again, two, how do you decommission these accounts? And this usually translates into some concept of federation, where you're federating this access to AWS itself. And that translates into roles, which are just a way of applying the concept of least privilege to specific functions or actions that need to happen within your account, but you're not dedicating long-term credentials to those. So when you need to actually do an access, for those who manage like operating systems like Unix or Linux, using the concept of sudo. That's the same concept as here. It's just you're switching to that role to do that action, and then when you're done, you're out, and those credentials are expired. This is the exact same approach to doing that. Now we're getting into the actual VPC design that you do. I mean, there's many different ways to design VPCs, and many people think of them as data centers. But as we know, the concept of data centers, or even some people call them regions, but they're not equal. Not the same within AWS and not outside of AWS. At AWS, there's some real key differentiators that you need to take advantage of. You should consider incorporating into all your designs. And this starts with the concept of multiple availability zones. Regardless of which region you choose throughout the world from AWS, you have at least 2 availability zones you can incorporate into your VPCs. Some you can go up to 5. These availability zones are separated from one another to allow for risks to be mitigated. Some are environmental, whether floodplain or fault lines. Others are more physical in nature, connectivity, so dealing with power or networking. But more importantly, they're close enough to allow a lot of low latency connections between them, between the availability zones, to enable things like synchronous replication between your data layers. That's a huge enabler. And so that allows you to build a lot of high degree of resiliency and availability into design with very little cost associated with it or complexity. The second is the concept of subnets within a VPC. This is a little bit of a different subject on why you create subnets within AWS, specifically within a VPC. You don't create subnets from an isolation perspective. You create them for specific routing requirements, and that usually translates into the concept of what's a publicly routable subnet and what's a privately routable subnet. So understanding what pieces of your architecture actually need to run in what tier and what subnet and the routing requirements of them is really key to understand before you design your VPCs themselves. As you'll find, the majority of your infrastructure will be able to run within the private subnets themselves, but you need to start understanding why you're going to create more subnets than actually are depicted on this diagram as well. But the other piece to consider is within a VPC itself, there's multiple ingress and egress paths, or inbound and outbound paths to access or be accessed within that VPC itself. But by default, when you create a VPC itself, it's completely isolated. You have none. So understanding what those access patterns are allows you to not only provide it, but actually control how that traffic is actually being routed outside of your VPC and the path that they're actually going to take. And as we saw, that there's multiple paths that traffic can take to go in and out of your VPC. This can come down to users needing access to the applications through the public internet or through a private connectivity from your on-premise. This could be accessing shared services from your environment VPCs to your shared service. But also, how are you actually managing this VPC? How are you doing patching? How are you doing backups? How are you doing deployments? So understanding the access paths that are of the data traveling in and out of the VPC is really crucial, because then you start planning and standardizing your routing requirements for traffic that's flowing in and out of your VPCs itself. So the more you're able to catalog these, you can make a much more standard routing paths and much more consistent, and you can provide a lot more security and visibility into the paths versus just letting things go as necessary. And lastly, not lastly, but moving into the actual concept of continuous compliance. Architecting for compliance standards or security baseline is a very arduous and laborious task itself. Many times it's a point-in-time activity, though. As you know, our environments are living. What happens on day 2, day 3, day 4 when we're actually applying and maintaining these environments? What's the impact to the baseline I architected for? Leveraging a lot of the event-driven kind of capabilities at AWS allows you to both enforce, but also prove your compliance to the security baseline at a moment's notice. So things like CloudTrail or CloudWatch events or config rules provide that visibility. What is happening approved or denied within my account? What is this change that's happening? But more importantly, you can apply remediation against things that fall outside of your compliance baseline itself versus waiting for an audit or things like that. So the more you can build into your compliance requirements into your event-driven architecture, the more you're able to prove and maintain those architectures themselves at a moment's notice. Also, moving into the concept of using infrastructure as code allows you to incorporate things like deployment pipelines and CI/CD type of approaches to how you maintain your architecture. So instead of doing things manually through the console and everyone has access to make changes through it, you provide a much more streamlined approach to actually how you manage your infrastructure within your accounts. This allows you to get a lot more predictable and test before you actually deploy into your production environments. But more importantly, everything's going to be versioned as well. So there's only so much testing you can do to actually improve that something's going to work. If you have unintended consequences on something being deployed, well, you can easily revert back to that previous version of that infrastructure itself. So that's a much different way of approaching change in your environment. So change is a very risky thing. It's just finding ways to mitigate it, prevent it up front, test it, but also provide a way to mitigate it if something unintended happens. And then also providing that visibility and providing a holistic inspection of the environment, leveraging that security and centralized approach to kind of get that deep level analysis of all the activity happening within your account using a single tool provides a great level of visibility control over what's happening within your environment. And then it comes to the concept of, okay, how do I actually implement this? AWS provides a wealth of resources, as you know, to enable you to build and operate your own landing zone. You can leverage things like solution architects or professional services as well to help you, go through that multiple phase approach to help build your own. But building is one thing. You have to maintain it and develop the skill set as well, which is absolutely possible. But you may need to supplement this with third-party tools as well to kind of fill in gaps or fill in other functionality that you need. But attracting and developing that type of skill set within your organization can be a challenge as well. You also may not want to develop these types of competencies and make them a responsibility as well. It's not part of your core competency, and you don't want it to be. This is where partners really help fill this gap. They reduce the burden on your organization to transform to this new operating model, and allow you to focus on areas that you actually differentiate yourselves in. One partner example is 1901 Group, and I want to bring Zach up to provide some good overview of how 1901 is really evolving and supporting the migration space in this world. So, great, thanks, Zach.
Thanks, Joe. I'll take the pointer.
Sorry.
Great, thank you. So until recently in the federal space, most of what the government's been doing with cloud has been really ancillary services like, let's see if we can back up some things into cloud, or maybe archive some things, or let's see if we can launch a website, or maybe do some compute task, dev or test sorts of things that are ephemeral. But increasingly, probably many people in the room are seeing that the federal government is asking for production workloads to move into cloud, right? And Joe has just laid out some of the AWS best practices for how you build that landing zone, the starting point. It's a starting point, right? If you go back to his slide on the lines all over the place, what is your starting point? You need to start somewhere. Those best practices are the starting point. But now what do you do with that? How do you actually take an enterprise set of services and convert them into a project plan and actually get in there? What do you do? Well, one question I have for everyone in here is, one of these days, one of your customers is going to say, you know what, I'm convinced. This is awesome, this is great, I want to go to cloud. You, take me there. And all of a sudden, you've got an elephant on your hands. There is an elephant in the room. You are moving your federal customers' mission-critical production workload into the cloud. Now, how do you eat an elephant? One bite at a time, okay. It is an elephant, and what you don't want is to be stuck in that spot of buzzing all around, because it's the easiest thing in the world. One of the dangers of cloud, of AWS, you can create an account and start shoving things in there, show it to your customer, they're thrilled, I want more, and all of a sudden you've got a mess on your hands, right? And not only is it a mess and you can't maintain it, but it gets really expensive really quickly. And then you're looking at your customer and your customer is saying, why is my bill 5 times higher than you told me it would be? All right, this is serious. So what we're going to talk about is the reference architectures and best practices. They're demonstrated a lot. You're going to see the slides all the time. You're going to see all blah, blah. And it's really important. It's really good. What's important about it is Amazon has actually been using that for its infrastructure for years. So that stuff is important, right? You need to learn it. But what do you do? How do you actually prepare an enterprise to go into those reference architectures? That's what this is about. We're going to focus on a couple key practices that we do in the pre-migration phase in order to get ready to do it in a structured way, a low-risk way, a way that your customer gets excited about instead of afraid of. All right? This is our company, 1901 Group. Our founder and CEO, Sonu Singh, is in the room here. And Sonu and the partners launched the company with a vision to make operations and maintenance of large-scale IT efficient and cost-effective. Let's bring right process. Let's bring strong automation. Let's bring great tools. Let's bring leveraged teams and leveraged approaches to the problem of large-scale enterprise operations and maintenance, right? And that's what we do, and we've been doing that for about 8 years now. Many federal customers, many commercial customers. We're only listing federal here just because of the nature of this particular audience. Our services are full stack. We work in managed services across the entire enterprise, any aspect of the data center really, as well as engineering and some software development, security, that sort of thing. I would love to go into our automated tool stack and our Insight platform. That's our branded platform that automates a lot of these behaviors, but it's not really the topic for today. The vision of the company was this sort of approach. Cloud is a natural extension of this approach. In fact, cloud allows you and your customers to automate, to orchestrate, to be efficient, to reduce cost, all of those things. It's absolutely true. And it's also got this dark side that if you quote unquote do it wrong, you can have an even bigger problem, right? Now, a couple distinctives, and this is why Joe asked us to join the conference here. Our company has invested very heavily in becoming a federal partner. We've gone through FedRAMP authorization. We recently went through Rev 4, for those of you who know what FedRAMP is and the compliance levels. And we've developed CMMI accreditations and ISO 9001 accreditations. This positions 1901 Group uniquely as a cloud managed services provider with these accreditations. We can reach many, many federal agencies. And because of that, we've been able to bring our ideas and our platforms to our federal customers, and we're generating a lot of excitement. So moving forward here. What we're now doing is taking a highly structured approach to going from the data center to the cloud. We call it our cloud factory, pretty common term. And this graphic right here shows you the components of it. What we have, you can see there are 5 lifecycle phases. We go into a customer, we transition and activate in. And this is highly defined. We optimize their legacy systems with our current O&M processes and approaches. We do cloud pre-migration. That's what we're going to get into right after this slide. Then we do the migration and we optimize in cloud. And then within those 5 lifecycle phases, we have the 4 competencies. We have our specific approaches. You're going to see some of that today. We have all of the materials, the tools, the checklists, the templates. You need those things to do this efficiently. We have tooling. There's some fantastic tooling that's developing. There's some tooling that will waste your time. You have to be very selective about the tooling that you use. And then we're building our team, and that may be one of the very most important parts. I have a whole slide on it. Here's our team. If you don't have, first, a methodology, and second, a competent team, you won't really be able to do the steps we're about to talk about. A couple comments I wanted to make about this. You need a multifunctional team. Traditionally in data center, you've got your server team and your storage and virtualization and your network and well, a true cloud architecture and migration team needs to be multifunctional. It's not that everybody's a jack of all trades and master of none. It's that it's multifunctional. That everybody has, we like to say, everybody has their major and then some minors. You major in servers and you minor in network and storage, that kind of thing, right? You've got to learn. Now, the interesting thing is, see that second block of learning, certifications, training, being mentored, that sort of thing? Everybody goes to that immediately. We want our AWS cert. The AWS certs are amazing. In fact, 1901 Group has a goal of 100 AWS certified employees in 2017. So it's very serious and it's amazing. You need the certs. However, nothing at all substitutes for the hands-on and the using of AWS services in your own infrastructure, in your own company, right? So I'm sure many people in here know that. I'm sure everybody knows that. AWS makes it easy. Go create an account, log in, download some of the white papers. It has the stuff that Joe was just talking about, and do it. Create an EC2 instance. Spin up an S3 bucket. Just do this stuff. When you do it, you immediately understand it. You can speak to it. You can talk to your customers about it. You can show it. So I really want to encourage everybody that while you're going down the certification path, you are putting your hands on it and you're bringing it into your own companies. Not at all a shill for AWS in case it sounds that way. You have to use it in order to be effective for your customers. So you can tell your customers how it really works and help them understand their perceived risks, right? We'll get to risks in a minute, and they really are perceived risks, not actual risks. This is a common graphic, AWS best practice graphic, the typical migration strategies. The idea here is you look at your enterprise and you look at the various systems, the platforms, the services that you have, and you categorize each one of those into a certain migration strategy path. Right? You can see on the graphic, for example, there's rehosting, there's refactoring, there's retire, shut it down and get rid of it. Right? This is a very common graphic. Now we're going to get to the really specific meat of what we're talking about here. How do you turn the view of a data center into that graphic? Okay? And one thing to notice on that graphic, see the gray dotted line that's coming up over the top? One of the most effective things you can do for your customer and to ensure your migration success is to stay away from that gray line. The more manual effort you have to do, the harder it'll be. Now, there's always going to be a lot of manual effort. I'm not saying there's none, but I'm saying you really want to look for leveraging the AWS tools that are available to you, third-party vendor tools that are becoming more and more powerful, more and more usable. And automate this as much as you can. This slide is a little mechanical, a little industrial, and it's really the meat of what we're going to talk about. This is an incredibly important slide, and by doing what this process shows on this slide, we've brought tremendous benefit to our customers. Okay? This is how you take an enterprise data center and turn it into that migration strategy view. Why the matryoshkas? Because, as you know, anytime you dig into something in your enterprise, you find the next thing, and the next thing, and the next thing. And to some degree, there can be an infinite regress. And that's why Joe said you need to do your scoping in, assess in 1 month, and then no longer than 4, 5, 6 months, absolute max, probably 4 months, do you do your migration planning, right? Because you could spend years doing this. You could spend years just untangling the custom applications, okay? At a certain point, you've hit diminishing returns. And you need to be really careful, or you can spend a lot of your customers' money and giving them not a lot of value. Okay, what does launch stack view discovery activities mean? Stack view, very simple. Just start with the stack. There's a room. It has racks in it. The rack has servers in it and storage, right? Start with your hardware. The hardware has server OSs loaded onto it, appliance OSs. The OSs have middleware, application servers, third-party tools. Those components have application code on them. There are network components. There are security components. Decompose your stack. You're going to take that one piece at a time. You're not going to lose the interactions, but that's your starting point. Otherwise, where do you start? You could theoretically start in other places. Sure, this is an easy way. Now you have to discover about it. Has anybody in here been in an environment where every aspect of all the systems is perfectly documented and they hand you the book and it's great? Ah, right. Of course not. So this is really heavy work here. Automated discovery, manual discovery. Let's talk about these. What are you actually doing? Let's start with manual discovery first. It's very laborious, it's very time consuming, there's no way around it. You need to extract whatever documentation exists. That's the inspection. You're going to actually put your hands on gear. You're going to look at configurations. You're going to see how many servers are out there. You're going to look in vCenter, Hyper-V, whatever. You're going to look at storage arrays, all of this. Now, you'll have a team. You'll have experts who are helping you put this together, but you need to look across that from the stack view and document what you find. There will be some documentation. It's always out of date. That's okay. Take that documentation as a starting point, consolidate it, put your hands on the gear, inspect. And then interview. As you're inspecting, you are also talking with the people who know. There's always institutional knowledge. There are always employees who have been there forever. They know things. You want to find them. There are business users who may not be technical, but they know things. You want to find them. You want to interview them, actually talk to them. And when you talk to them and you bring all this together, you create a document. Okay? Pop up to automated discovery. There's a lovely desire to push a button and everything is just clear and beautiful. And if only it could be. And in theory, it could be, right? If we did everything right, it could actually happen. And as we do things like move to cloud, we get closer and closer and closer to that. That's true. But in the typical data center, you can't do that. You can use very common tools that are already out there, Active Directory, SCCM, BigFix, your scanning tools like Nessus. There are many tools that you're going to find in any environment, and you can use those tools to get pretty solid information, automated discovery. Then you may have your own tools. There are many tools on the market that can scrape information from the enterprise and provide you a mapping, a dependency mapping, an endpoint mapping, that sort of thing. Caution. You can get super wrapped around that axle. You can spend all your time messing with that tool and trying to tune it and trying to get it right, and weeks and months go by and you don't have actionable data, right? So you definitely want to use automated tooling as much as you can, but you also need to be careful with it. So you take that tool's output, you take the data from the tools coming out, you take your inspection findings, and you take your interview findings, and you put this together into a document. And this takes some real work. Excel is great. Keep it simple. Even in large infrastructures, even with hundreds and hundreds of databases, hundreds of applications, 1,000 servers, whatever. Excel's great. Put it in there, or whatever works for you. Now, when you take this document to your customer, they're not going to believe it. They've wanted this for the last decade, and they've never been able to get it. The point being that the pre-migration step of this kind of discovery provides immense value to your customer. They're not even in cloud yet, and you've already provided them value. When they have that document in front of them, they can make vendor licensing decisions, capacity planning decisions, staffing decisions, technology refresh decisions, all kinds of things like that. Then you go from there. Technology family analysis and decomposition. Is moving a Java J2EE application the same thing as transitioning from Solaris to Red Hat Enterprise Linux? No, of course it isn't, right? Some of this is pretty simple. And what you do is you look across this discovery document and you find families of technologies that are similar. You will find servers, you will find storage, you'll find applications. That same Java J2EE stack, it's not going to have the same migration path as a Power Builder stack. And I'm talking about some real world examples now that you're going to see in a minute. So you put these things together in like families, right? And what is the criteria for does it go into a family? The criteria is what do you have to do to the thing to get it cloud ready, to migrate it in? And you're going to find clusters that you do the same thing to those clusters to get it into AWS. Whatever that thing is, you're going to do that to those clusters. It might surprise you sometimes that those clusters are seemingly unlike. So going back to this, you then have your technology family view. This is a beautiful document. I'll show you a very tiny example of it next. When you put that in front of your customer, then they say, oh, wow. And we'll talk about why in a minute. Then you map to each of those technology families the AWS migration strategies right here, right? So now you've taken your enterprise, you've decomposed it into technology families and aligned each technology family to the AWS best practice migration strategy model. You're ready to go. Here's an example. This is a live customer example. When you do this, you are creating best practice work blocks. You can immediately visualize your project. You can immediately see, this is what I have to do. Here's the actual work. You can schedule it. You can plan it. You can determine what types of skill sets do you need? What does your team composition need to look like? How much money do you need to ask the customer for? What can they expect to receive after how many weeks or months, right? A couple examples here. Notice I started with the general AWS environment. The truth is the landing zone concept is layered. You know, the first layer of it is that general AWS environment. It's exactly what Joe put out there. You want to start with that best practice that meets your customer's needs. Then you begin layering into that the landing zone implications of your technology families, right? Next, you might typically go to the customer's enterprise services and tools. Get their security services, get their Active Directory in there, as Joe mentioned, et cetera. You're going to find a bunch of migratable apps. You can use a tool, you can just copy them over, whatever, that's great, you know? Then you're going to find things like Power Builder to generic platform. Someone's got an ancient Power Builder, bunch of apps, and they say, we want that to run out of cloud, you know, on web. And you look at the thing and, you know, and then you find tools. There are actually great tools that will convert Power Builder into, you know, JSF web stacks. And you can deploy that sort of thing and get you 80, 90% of the way there, and then do the manual work. Now here's something very interesting. By the way, the periodic table there is just to illustrate, again, the technology family concept, that the yellow stuff in the middle, they might be different components, but they're like each other. Whereas the stuff on the ends, they're not like each other at all. And yet they're all in the data center and they're all related. The last item on there will be one of the most exciting things that happens to you. As you show this to your customer, they begin to see a real world shape of how this can be done. They begin to see risk, which we're going to come to in a moment, and they begin to get excited. Wow, this can actually happen. And I don't mean just to stuff a bunch of stuff in Glacier. I mean our entire production workloads in the cloud. It actually can happen, right? So then they say, well, you know, we need this new service built. Do you think you could do that? And then all of a sudden you say, absolutely. You're going to cloud. Now you can take advantage of all these amazing things. And when we go to the next slide a little bit later on this, you'll see specifically that request. That's a real request from a customer. Risk. Risk is interesting. Joe reminded me of something really, really important this morning. You know, if you're a PMP trained person or just a very structured methodology person, you tend to think of risk as, you know, you identify the risk and you go through the process, severity and impact and all that stuff. Joe reminded me this morning, risk is about perceived risk. It's about perceived risk. What does the customer think is concerning? What keeps them awake at night? What is going to prevent them from closing the deal, from going to cloud? One of the things that we've learned early is identify those risks. Talk to your customer. Listen to them. What are they really worried about? Here are some real world risks that some of our customers have been concerned about. Are they actually risks, though, or are they perceived? Because if you look at the risk and you look at the mitigation approach, in fact, all of these points on here are rather easily dealt with and rather easily mitigated if you plan for it. So when you go to your customer, you've decomposed into technology families and migration strategies, you understand their risks, you can create a very clear and specific view of, hey, I know what you're worried about, and we're addressing that, and here it is. Here's how we're addressing it. Nothing will help get you buy-in more effectively than that, because that risk is perceived to them when they see that it's not going to result in impact. People get really excited. Let's talk about the bottom line, the potential for unexpected costs. Has anybody in here run into a situation where your cloud deployments have run into unexpected costs? Has that happened? Okay, there. Yeah, a number of people. Anyone over here? Yeah. Right. There are all sorts of reasons for it. And, you know, one of the models that you want to stay away from, obviously, is well, you know what? It's on demand for the customer. So, you know, they decided to use more, so it's on them. Obviously, you don't ever want to be in that position. You want to be in a position of making sure your customer understands what they're doing. We've developed the concept of elasticity engineering. What elasticity engineering does is it sizes appropriately going into cloud, right? So when typically when Fed buys data center equipment, they buy for the maximum case. And so when you go and look at utilization on devices, you tend to see two patterns. One pattern is everything is completely pegged and it barely runs because it's old and needs to be replaced. The other pattern is it's at 2% utilization because it's drastically oversized. Because one day a year, you know, 10 million people use the website, right? You tend to see a lot of that. With elasticity engineering, you do performance baselining in the discovery, and you go into cloud. You build your landing zone going into cloud so it's right-sized. Right-sized for compute, for the actual, you know, the workload itself, and right-sized for cost. And then when you're thinking about that day, you know, once a year when 10 million people hit the site, fine, plan for it and use auto-scaling or other tools like that, and no problem. And you can tell your customer, by the way, that day is going to cost you more than the whole year, but that's fine because they know. Then when you're in, you've right-sized going in, you continuously monitor utilization patterns. Joe mentioned single pane of glass, billing. You know, there are best practices and there's tooling for this. And what you're doing is you're constantly looking at the behavior of the systems, the behavior of the applications, and frankly, the behavior of the users. You know, is every Tuesday, you know, a dead day? Great, scale down. Charge your customer less. You want to find that, and you want to do it on an ongoing basis. Amazon has put out some information about this at one of the summits recently, and one customer reduced their costs by over 80% by doing effective elasticity engineering. So again, you want to bring those perceived risks up and speak to them as early as you can. And you really want to talk about elasticity engineering. So you get true value out of cloud. The last thing you want is to go to cloud and it's more expensive. Okay, so now you've got some actionable data in your hand. You've decomposed into technology families, into migration strategy. You've dealt with the risks. You've done your elasticity engineering. You're ready to actually start building and migrating. Everybody's excited. The best place to start, hands down, is with Amazon Reference Architectures. Here we have the sort of standard out-of-the-box reference architecture. This is sort of the baseline that everybody works with, everybody sees. You'll see this picture everywhere. You know, 2 regions, multi-availability zones in each region, load balance through ELB, et cetera. For many enterprise use cases, this is a great starting point. It's not going to be the right starting point for everything, but Amazon publishes numerous best practice reference architectures. Start with one of those. Find the one that looks closest to your customer, right? Because what that does is, one of the most effective things it does is it minimizes design sprawl. Design sprawl. You start designing and all of a sudden you're adding this and you're adding that and you're doing this and all these things happen and the next thing you know you're in that spaghetti land again and you can't control it. And all you're doing is creating a new monster in the cloud. Now we get to actually building that landing zone. You take those implementation details that you learned from the decomp into technology families and migration strategy. And you've got the third column now, landing zone considerations. You now have very specific details that you build into AWS reference architectures. So you construct your reference architectures the way Joe mentioned. and then you build into those reference architectures the specific landing zone considerations that come out of your technology families and their migration strategies. This allows you to move in a stepwise fashion. You can roll things out in various ways according to what your customer needs. Okay? It also, as I put up there, decouples the technology family itself from the overall environment. So you're not worried so much about hooking into the environment. You've already used an HA, high availability, best practice reference architecture. Okay, we're coming to the end of time here, so I'm going to recap. What we're saying is if you do structured pre-migration discovery, you end up with an actionable and accurate decomposition of your technology families and your AWS best practice migration strategies. Your customer will be thrilled. When they see this in a document in front of them, they'll be thrilled. It's great. That migration strategy view leads to specific landing zone implications. Okay? Very specific design details, actions you take during migration. When you put those specific implementation details into AWS's best practice architectures, that gives you the full picture. You're now reducing risk, ensuring security, high availability, all of that, and most importantly, migration success. At that point, you go from the kid with cardboard to, let's go, it's real. This works. There are many ways to do it, but this works. I'm going to turn it back over to Joe here in just a moment. I want to introduce Ben Hilton-Smith. Ben, could you stand up? Ben is our senior cloud architect in the company in 1901 Group. He's going to be available at our booth and after if you have any detailed tech questions. And I really appreciate your time. Thank you.
All right. Thank you again for attending this session. As I showed the slide before about the whole migration track itself, all the content and the videos themselves were posted on Amazon Web Services YouTube channel for future review. And Zach, myself, and Ben are available for questions afterward offline as well. Thank you again.